Ow! Roll. Oh, hi there, me huppies. Guess what we're doing today? No, wait, let me guess. Oh, I forgot. Come over here, Byron. Yes? Sailor wants me to guess what we're doing today, but I don't know what we're doing. Okay, I could figure this out. It's math. Yes, that's right. Ooh, math. I like math, but it's kind of hard. Yeah, math class is a pretty difficult course. But, practice makes perfect, so no need to feel worried. I wonder what this says. Dear family, your child is learning math in an innovative program called Math Expressions. Ooh, exciting! The program emphasizes understanding and fluency. Your child will connect math to daily life, solve a problem by understanding and representing the situation, and then finding the solution, and work with and explain strategies to other students. Oh, this is very important, guys. You must do these 3 things in order to succeed in class. Visualizing and talking about math is very important. This approach helps children feel that they can learn math. They do learn math, enjoy doing so, and feel good about themselves as math learners. We feel good about learning math too. But, why is effort important? Recent research shows that effort is important in getting smarter and in doing well in math. Oh yeah, that's why. Obviously, duh. This is called effort-produced ability. Students who work hard, think and participate in class, and do their homework do learn math. So encourage your child to work hard, and to know that he or she can learn math. Your child will have math homework almost every day. Homework is important for math learning. Yes, it could be daunting, I know. The homework is not supposed to be a waste of time. The homework is supposed to show you that you can learn something new by just doing it. Make a special time for homework in a quiet place. For example, no TV. Ask your child to explain to you some problem he or she did. So, if your parents want to help you, you better explain the problem to them, because they will not know the purpose of the homework if you don't tell them the problem. To make concepts clearer, the Math Expressions program uses some special methods and visual supports. Some of these for Unit 1 are shown on the back of this letter. Ooh, the back of this letter? Wow. If your child has problems with math, please contact me to see how we can work together to help your child. Thank you. You are vital to your child's learning. Sincerely, your child's teacher. So there's actually something denoted to Unit 1 at the back of this letter? Yeah, Byron read it, and we listened. Yes, apparently dogs are very good listeners. Trot! But, forget about that. Let's see what we're learning today. Huh? Oh, we're not learning about that today. Skip it. What is it? It's about ratios and ratio tables. We will learn about those later. For now, what we are learning is the actual start of 6th grade. Now, usually, 6th grade is the first year of junior high school, and you guys gotta prepare for junior high, because 6th grade ain't easy. 6th grade is the transitioning from a playful elementary environment to an academic junior high society, kind of. Well, not society, but you know what I mean. You know what I mean. It's just a transition. But depending on the type of district, 6th grade may also be the last year of elementary school. So, yeah. Be prepared and see which one 6th grade falls on. Anyways, as I said, we won't be learning about those today, but we will be learning something very important. We will be learning something that you guys should have already known from previous grades, like 5th grade, 4th grade, and even 3rd grade. It's multiplication. Multiplication. Wow. What are these? These are multiplication tables. Yes, I just learned about those. Discuss patterns in the multiplication table. Look for patterns in the multiplication tables. Ooh, there are patterns? Yes, every math visual has patterns. Otherwise, it's not a math visual. For example, a circle is always round and round and round again. If it does not have that pattern, then it's simply not a circle. A square has 4 right angles again and again. If it doesn't, it's just not a square. So it does have patterns and sequences. We're not talking about shapes today, but I think you get where I'm going with this. It's the same thing for these multiplication tables, except they are both the same, but they both each have different patterns. What do you notice about these? Ooh, they are organized. That's right. The numbers are organized into columns and rows. You should have learned about columns and rows from 2nd grade. Yes, columns and rows are very special lines, up or horizontal, that tell you how an array is arranged. Yes, you should have learned arrays from 2nd grade and 3rd grade too. This is not what we learned in 6th grade, but it is a pattern that we should learn because it's very important. What do you notice about these numbers? Just think about it for a second. What do you notice about the, let's say 4 one. Let's say the 4 one. What about the 4? Ooh, there's a pattern. The next number is 4 greater than the previous one. That's right. 4, 8, 12, 16, 20, 24, 28, 32, 36. Yes, they are 4 greater than the number that is previous, because 8 is 4 greater than 4. You are right. The patterns on the multiplication tables will better help you understand why these are in daily life in the first place. Yes. And this will make you wonder, are there more than 10 or perhaps 5 patterns in there? Could there be more patterns the more objects we gather up? How about if we do less objects? Will less patterns show? Yeah. These are some observations you should gather up. And it's the same thing horizontally. It's just horizontally. Ew. Yeah. So these patterns are the same, but in a different structure. Columns and rows. Strategies for finding factors. Factors? Wait a minute. Hang on. What's a factor? That's a good question. A factor is one of the numbers in a multiplication problem that multiply together to find the product. And the product is the answer of a multiplication problem. Write the unknown factors and the unknown product. Let's see. Look! There are 1, 2 red areas and 1, 2 blue areas. There are 2 red areas and 2 blue ones. Wait a second. N is not a number. N cannot be a number because it is a letter. Ah, but you're forgetting. N is a variable, which means we can substitute it for any number. Oh, yeah, right. But in this case, we should not substitute it for any number. We have to substitute it for a certain number because something is missing. Okay, let's work together to figure it out. Let's see. Well, we know that 2 times 3 is 6, and 2 times 5 is 10. So 6 and 10 are cleared out of the way. 7 times 3 is 21. And 7 times 5 equals... Oh no! N is missing. Wait a second. N must be 35, because 7 times 5 is 35. Bingo, that's right. There is also another way we could find the factors and products in the multiplication problem, which I like to call factor puzzles. Ooh, factor puzzles. Factor puzzles are like small puzzles. Like, do you know Sudoku? Yeah, it's a puzzle with numbers, I believe. Yeah, this does not look like Sudoku, but it kind of has a similar structure to Sudoku. But anyway, it's kind of like Sudoku, except it's not Sudoku. It's a factor puzzle. Wait a second, we already did these before. 2 times 3 is 6, 2 times 5 is 10, 7 times 3 is 21, and 7 times 5 is 35. We could solve factors and products using factor puzzles too. That's correct. And also, we could do the same thing from the other side. 5 times 2 is 10. 5 times 7 is 35. 7 times 5 or 5 times 7. 2 times 5 or 5 times 2. They will always get the same answer due to the commutative property of multiplication. Yeah. Let's go to the last page. Now, let's see about these tables. Let's see if we could solve these ones. Write the unknown factors and the unknown product for these tables. Let's see. What do you guys think? Do you want to solve the puzzle using the multiplication table or the factor puzzle? How about we solve question number 2 with the multiplication table and question number 3 with the factor puzzle? That seems like a good idea. Okay, let's look at this multiplication table. Well, for starters, we obviously know that 0 times 0 is 0, but that's not where we're going to, are we? Nuh-uh, no siree. We need to look at these 4 numbers. Yes. Wait a minute. But n is not a number, it's a variable. Well, yeah, but variables represent numbers. Oh, I see. Okay, so, wait a minute. We already did 6 and 21 in the previous one. There's 6 and 21 in there too. 3 times 2 is 6. 3 times 7 is 21. 8 times 2 is 16. Which means the 4th one is n. Let's see, how are we going to solve for n? Well, one way we could do it is that we could multiply 8 by 7. But in order to do that, we need to count by 8 7 times. Wait a minute. If we're recalling, that process is called skip counting. You should remember skip counting too. Skip counting is pretty difficult, but once you'll get used to it, it will feel like a breeze. Let's skip count 7 times. 8, 16, 24, 32, 40, 48. Plus 8 more. That is 56. That's right. Plus, if we skip count by 7s 8 times, 7, 14, 21, 28, 35, 42, 49, 56. Yes! And it's 56. Woohoo! Oh, yeah. Looks like you guys are going to get the hang of this. Okay. Now, this is kind of a tricky one because all the numbers are already filled in. Sorry, not filled. They are already filled in for you. What? That's ridiculous. So did the problem already solve itself? Nuh-uh. The problem is unsolved. But then how are all the numbers substituted? You have to go to the factor puzzle to solve this problem. Oh, yeah! Let's see. 6, 35, 15. Oh! Yeah! The 14 is missing. Oh! That was very simple. Yes, that was very simple. Because the only way to solve this problem is to look back at the multiplication table. 6 matches up with that 6. 35 matches up with 35, obviously. 15 matches up with 15. And the unknown matches up with this location, which is 14. So you basically just had to look at the multiplication table in order to fill in this blank. Yes, so n is 14, even though it's already solved. 7 times 2 is 14. 2 times 3 is 6. 7 times 5 is 35. 5 times 7 is 35. 3 times 5 is 15. And 3 times 2 is 6. Wow, looks like we're getting the hang of this. Yes. Now, this is one thing that I like to call check understanding. It's an optional question. You don't have to answer it, but it kind of advances your brain. It kind of trains your brain. Like, the brain likes training and the brain likes knowledge. So, explain how a factor puzzle is related to the multiplication table. Okay, let's look back to the first page. What do you notice about the factor puzzle and the multiplication table? Well, for one thing, the multiplication table is split into lots of small squares. 6 is in a small square. That's right. What do you notice about the factor puzzle? It's also split into squares, and 6 is also in a small square. Wait a second. The multiplication table and the factor puzzle are similar, except the factor puzzle looks like a mini multiplication table. Wow, really? Yeah. This 2 represents this 2. This 10 represents this 10. So it's basically the same, except with the structure. It's like a mini multiplication table. Yeah. It's like mini multiplication's what I like to call it. It's a puzzle for factors. Yeah, you're right. It is indeed a puzzle for factors. Because if we look here, 3 and 2 represent the factors, and 6 is the product. 3 times 2 are the factors, because they multiply together to get 6, which is the product. Well done, everyone. Looks like you're getting very good at this. Wait a second. I think I noticed something else. What do you notice? Well, if 7 times 3... No, wait, not 7 times 3. There's no 21, obviously. So, wait a minute. 7 times 2 is 14. 7 times 5 is 35. 5 times 3 is 15. 3 times 2 is 6. Wait a second. So, are you telling me that 2, 5... is the same as 2, 5 here, and 7, 3 here is the same as 7, 3 here? Oh yeah, I suppose so. I think the factors in a factor puzzle are the same. You are right, guys. I didn't notice that. 7 and 3 at the top is the same thing as 7 and 3 at the bottom. And 2 and 5 at the left are the same as 2 and 5 at the right. Wow, you guys are very smart. Well done. Well, unfortunately, that's enough for today. Oh, but I want to keep solving more multiplication mysteries. We're like math detectives. Oh, yeah. Right. We dogs are pretty good detectives. But, turns out, this was proven to be an easy mystery. But don't worry, there are harder mysteries, because 6th grade is a whole lot harder than that, guys. You don't just multiply numbers together. You need to find the volume of shapes, you need to understand geometry, you need to understand spheres and rectangular prisms, and oh my goodness, it's just a lot to learn. So, don't worry, this is definitely not over yet, because 6th grade has a lot more detail than just this. There are also more complicated concepts, which we'll get into later. But anyway, that's it. Already? That was quick. It's like that 19 minutes. Well, yeah, actually, this video has been running for 19 minutes, so... well, yeah, well done. You two are the ultimate math detectives. Yeah! Woo-hoo-hoo! And, if you want to solve more math mysteries, here is a present I give to you. Watch the toucan come alive in its tropical forest as they discover and solve math challenges. Download the Math World's AR app, available on Android or iOS devices. There's an app for that? Wait a minute. So you're saying I don't have to stop solving math mysteries? Of course not. You can download the Math World's AR app and watch the toucan come alive in its wonderland as you solve problems. Just tilt your device and click to the bubbles in order to solve the math mysteries. Wow! Where can I get this app? Well, it's very simple. You just go to the App Store and you type in Math Worlds AR. The app looks like a frog. So, let me just show you the app profile. Hold on. Give me a second. The app profile looks like this. If you see this frog face on the app, then that is the right app. So, yep, all the other math books surprisingly tell you to download the app too. So, yeah, pretty much. The app looks like this, with the frog face on it. If you see this, then this is the right app. If you don't, then you must have done something wrong. Okay? Alright, well, seems like we are pretty much done with the 6th grade lesson. Just gonna... never mind, I'll just put this here for now. Anyways, I'm Byron, I'm Sailor, and I'm Hans, signing out. Are there more math mysteries in here? Better. The app, remember? Oh yeah, let's download it. Where's my phone? I don't know. Well, I guess we'll just have to check with your phone then. Wait a minute, I have a phone? Oh, those guys. Oh, those cheeky little guys. You know what it feels like? It feels like that math is never going to end. Because math just keeps appearing every day. Every single day you find math. Like it's something simple as this. It's a line. A line is something in geometry. See? And look. There's literally a circle here. See? Geometry. This always contributes to math. So, if there were to be no mathematics, then all of the things, the whole entire world that you see, will no longer exist if math no longer exists. So, guys, we should be thankful that mathematics has appeared in our daily world. Thank you, math, for creating the world and for existing. Well, God created the world, but the world is a sphere, and sphere contributes to math. So, yeah, math is everywhere, guys. So, next time you see anything, like, I don't know, maybe like a dust spike, or a blue whale, I don't know, like a tiny dust speck, or a blue whale, just remember, it has to do with math. The blue whale's size, it's huge. You must have learned that in kindergarten. A dust speck is small. You should have learned that in kindergarten, see? That's math. Sizes contribute to math. Especially rectangles and shapes. They are very cool. Well, see you later, guys. Keep solving math mysteries and being math detectives. See you later. Bye. I am almost positive that you have a phone. Really? Yeah.